I have a device, okay, like I have a temperature sensor, and now I want to kind of read the data in the temperature sensor. If it allows, then I should be able to control it. How I can do it? Means it's a simple question. Or I have a different kind of a device, temperature sensor, or something else, some small robot is there that I need to kind of control it or read back its status. How I can do it? Okay, so if I connect the device to the computer, typically it will have I/O address or it will be mapped to memory, so it is memory mapped. And devices generally they have registers, control register, read registers. Okay, a write register means you have to write the data, you have to read the data, you have to control through tweaking the register. Okay, so what are the problems that we see? Means if device is connected, then kernel will be the kind of entity that will deal with the devices, and then it will have interrupts and so many things like serial and parallel port communication with the device. Okay, so if a user wants to access the device, then he will first it will try to take the memory mapped address and then its controls, and then it will start tweaking the registry. That much is not possible. Means we need to have a kind of a library kind of a entity. So that library entity would kind of it would sit in the kernel space, and it would be specialized for a particular hardware. Okay, so every hardware is different. So writing, so we are talking about device driver. Okay, so if I have a device, then there should be kind of a library. Means we understand library, right? If like I have a MySQL database, then along with that we receive one library, and we just tweak the library API, and it works with the database. Means this is general kind of software fundamentals. If I have anything new, if I have a kind of TCP/IP networking through a network card, then generally we will not do all the tweaking on the card. So we will have TCP/IP library. If we want to communicate with any external entity, we have socket library. So ready-made stuffs are available, library. So they provide simple C API that we need to use. But what about the hardware? If I have a hardware that is connected to a computer, then how I can kind of tweak the hardware? There should be one library. We can loosely connect that library with a device driver. Okay, so device driver, the name is a driver, a software that drive the device. So it will take care of tweaking the registers in the device, and it will take care of all the interrupts. So device driver concept came into the picture because we have n number of devices. Every one has different ground. So a person who is trying to use so many devices, he cannot write code. So can we have a kind of abstraction, a library format where the way it provides access to the user programming, so that should be constant, like read, write, and the way simple API happens, or IOCTL, through which we can kind of check its descriptor and its characteristic. So can we kind of have a library, or can have something like that where independent of the hardware, it would provide an interface to the user, and user can call those interfaces generic interfaces independent of the drivers, and then driver would receive those kind of requests, and then since drivers have addresses, so we can say that we want this driver, and then we start calling the generic API, and driver internally it would kind of read the generic API, and then it would make the register tweaking inside the device. Device driver, a driver, a library, a software that provides generic interface to the user programming, and then behind the scene device level register tweakings it would do. So writing device driver is an art, I would say, but way bigger art is understanding the device, because we know that device driver is going to provide these many interfaces to the kind of user space programming, but understanding the device. Every device is different. And then if we make a kind of a single bit mistake, then device would start behaving in erroneous way. It's something that is unusual. So first it would take kind of a good amount of time, days, weeks, to understand the device, and then we can kind of provide the interface to the user program, and then user program can write the call the APIs. So as we say that there are two levels of programming. One is user level and kernel level. So these two programmings are separate in the sense they don't share the buffers. So we can share the data in the buffer, and then we can make some kind of interrupts, user level interrupts, that a particular device driver would be kind of in a situation to handle it, and then it would start tweaking the devices. There are many device drivers that is already available in the program, like for handling of the RAM or disk, or for the keyboard, or to the mouse, or to the screen, and external device for external new devices. That anyway, then we have to kind of we have to write the driver. So devices it can be character based, it can be block based driver. So we will see we will introduce device driver, writing device driver, and then how we can deal with character based or block based devices, and then how we handle the interrupts, and then serial and parallel communications with the devices, like through the protocols like SPI, through I2C. So those we'll see. So device driver, how we can write, how we push inside the kernel. So we will make it kernel entity, and then after that how it provides interfaces to the user, and then it behaves like a kind of mediator. Okay, it's not MVC like we see design pattern model we control. So it's not MVC, it's not observer design pattern. It's a kind of mediator because it has intelligence, and then it mediates from user level to the device, and then it does the communication to and forth. So we can control the device through device driver. We can write device driver creating file system in RAM, or creating then using the file system. So it's a kind of character based or block based, and then we can have devices that is character based or block interrupts, and we talked about various serial and parallel communication that we'll see. So writing device driver on laptop, okay, so that is not something that is very practical. Okay, device should be device. Okay, so I have a microcontroller, Raspberry Pi 0. Okay, so this is what we will use. So at the beginning we will kind of write the driver and character and block modes. Then I'll take pen because there is no GPIO pins. So I have purchased GPIO pin, and it's a golden GPIO pin, and then I'll solder it, and then we will see kind of HMI kind of environment where we will have communications with the devices through interrupts or through SPI or I2C protocols. So that we'll see. So certainly we will have kind of a good time that we will see in a I think my finger is bigger than this computer. So this is not a kind of it's a microcontroller, but it's not less powerful than a powerful computer. It has 512 MB RAM, and we can divide into GPU also. So we can do OpenGL programming on this RAS. So I have a kind of Raspberry Pi. This is Raspberry Pi 0. I have 02W also, and then I have Raspberry Pi 3 also. Okay, but we will use this microcontroller. Anyway it is kept, so I think it is nice to use this rather than just keeping in a kind of some box. So we will see how we can write a device driver on Raspberry Pi 0W. That will